Close my eyes and we soar to infinity. We're going at the speed of light. Bring me higher. You lift my feet up from the ground. I wish upon the shooting star that you make me lighter. And I
Can you guys hear me in the chat? All right, there we go. Everyone can hear me all right? There we go. What's up, Mark? How's my keyboard? Not too loud today? Where's Smarky? You in here? Let's see. Doesn't look like our YouTube is matching up there. It says we got 0, but we got a couple people in YouTube. Alright, we have to fix that. JT. Is this where we learn how to set up a Naze 32 in clean flight? You know, I just took my last Naze 32 out of a quad maybe, I don't know, 2 months ago. You know what? It was a good flying quad, and so there was really no reason to replace that. I probably spent way too much time tuning it, but man, I really like the way it flew. You know, what ended that quad was hitting the electrical wires in front of R&L. That's what ended that one. No, I get it. It's a joke. I'm just saying, I still had Naze boards in my quads this summer. In one quad, not a lot of quads. In one quad. You still have a Naze to Flash BL Heli on a KISS build. Oh, yep. I've got I've got some old Lux boards for doing nonsense like that. And I got old boards for binding satellite receivers too. Because just about every flight controller out there has at least one thing wrong with it. There aren't too many out there that are absolutely perfect. And so you'll like everything on the flight board, but oh man, it doesn't bind satellites. You got to bind them somewhere else and then plug them in. All these silly things. All right. Who else in here? 11 people. Not bad. Not bad. I'm very happy. You guys figure out what kind of quad we're building tonight? Are we building a quad tonight? Maybe you guys are going to surprise me and tell me we're building something else. JT, Thunder. Who else is hiding out in here? I'm sure Bob's in here somewhere. Bob, where are you at? That's what I need to know. Death Star logo. I need to find the app that I need to install in order to show me everybody that's logged in, so I can give them a shout out. Right now I can't see you unless you're chatting to me. So I see JT, I see Fender, I see Mark, I see old Mark. I don't see new Mark. I'm sure new Mark's in here somewhere. All right. Pop over to SolidWorks here. All right, everything seems to be functioning. That's good. I've got chat. I've got my desktop. All right. Yeah, where's Smarky at? Text Smarky. Where are you at? I told him he's the ringleader. He probably can't figure out how to type into the chat. That's probably what the problem is. Where is everybody? Who's over on Twitch and then who's over on YouTube? He's busy posting everywhere. Is he in the Western New York Scalers right now? Can't type. YouTube doesn't work. Right, well, I guess maybe we can address that before we get too far. Let's see. YouTube doesn't work. No, JT. I see JT and Fender over on YouTube. They're chatting away. I can see them. There you are. There's Smarkies over on Twitch. What are you, signing up for a new Twitch account? YouTube is good? Alright. I'm just waiting for Digital Silence to give me that free Amazon Prime sub. You know it. You hit that button. Give me that sub. I want it. Doesn't cost you anything. You don't need to try the YouTube link. Smarky, you're fine in the... You're fine in Twitch. She working all right over there in Twitch? Smarky doesn't need any giveaways. He's already got everything coming to him. Jeez. You can't converse with the others. I see. I see. Well, you kind of can. You'll see him go by on the live stream. That's where you'll see him. On the video overlay, everything's combined. You've got both the Twitch and the YouTube ones coming through there. I think so, right? Need wife's reading glasses. Yeah, you are old. That's true. While you're figuring out how to get in here, and everyone figures out what we're going to build tonight, I'm going to see if I can't fix that YouTube overlay real quick. That's if I could remember how I made it. And one of these turkeys send me something. Ha. Well, perfect. Oh, no, it's not. Is it really? Is the Micro TX $100? That doesn't sound right. Is that right, JT? Is that $100 for that? That's way over SmartKey's spending limit. Sparky, you should bring your old Spectrum radio to the swap meet and get rid of that. Then you get the new radio. You guys, is there really a difference between the latency on that and the higher speed latency on the Spectrum? I never really looked into it. But you've got like you got what, 11 millisecond frame time on the Spectrum if you turn it up? Because if I was having problems with it dropping out, I'd be looking for it, but I haven't had any problems with the quads losing connection with the radio. Third of the latency of the Free Sky. You don't see a sub button? Oh. Am I not allowed to have subscribers yet because this is the first video? That would be sad. People say so. Crossfire is like 5. Okay. The Free Sky S-Bus is 16. Marky, you subbed? Yeah, you subbed on YouTube. That doesn't pay the bills. You gotta give me the Amazon Prime subscription. Alright. That one wasn't what I was looking for. Or what do we... Yeah, that's what I'm asking you. I know what I want to build. Actually, I don't tonight. Normally I know what I want to build, but tonight I want to build something for somebody else. Because, I got enough quads on the wall. There's got to be a dozen hanging up over the top of my computer. So let's build something else. I mean, I like small quads. Build something for that 250 gram class that we're going to be running. Freestyle or racing quad? Well, you guys are doing a lot of racing. 3-inch that will carry a session. Yeah. We can carry a session with a 3-inch. Absolutely. Here. I don't remember how I made that little overlay. 2-inch. A 2-inch quad. I don't like 2-inch. I don't like going below 2.5-inch. Because there seems to be a bit of a barrier, a bit of a difference in the efficiency once you go down below that 2.5. I hope you're asking the rest of the chat. Smarky says race or freestyle. I don't know. What are we building? You call it, Smarky. What are we making? Is that a racing quad? Racer? Alright. Let me pop over here. Okay, so I'm going to start with a new assembly. Racer. 2 votes race. Smarky called it. We're doing a racer. Alright. Race for the win. What do you guys think the first part I start with is? There's one part that I always start my design with, because that part determines everything else. You guys take a crack at what part that is. Well, no, there's not too much of a difference between race and freestyle, is there? I mean, you can use either one for both and they work just as well, but I think there's certain things that prop circumference, that's right. I'll always start with the props, because that's going to be what determines everything down the line. Flight controller? Nope, sorry, you suck. Sorry, Mark. Alright. Over to my top plane. So this is a top-down view of the quad. And I'll start with a little sketch. Alright. And there is our prop. What size prop are we going to be running on this racing quad? We doing 4-inch? You're gonna do a 4-inch quad? What do you think? 4? Alright, so I've drawn a circle from my top view, and I've called this 4 inches, right? Now, 5-inch for JT. Smarky is spamming with 4. So we're gonna go with 4 or 5. Well, you know what? we're going to be able to change it at any point here. Once I have my prop size, I'm going to start mirroring that across my two axes there. All right. Now I've got my quad. I've mirrored those props across the left right plane and the front plane. Just because Smarky spams the chat doesn't mean we have to listen to him. He does talk a lot. That is true. Okay. If we were going to do a pure X quad, what I would do is just give myself a little 45-degree angle right there. And that means that my quad is locked into an X configuration there. But I don't think we need to do that. We could run the stretch frame for Quest. We could do the wide frame. I heard somebody call this the toilet tank configuration, and you run your battery sideways so that it looks like you're carrying a toilet tank around with you. I thought that was good. I thought that's funny. Okay, I am going to set the clearance between the props here. So depending on how crazy you want to get, let's say we'll put like a 1/3 of an inch between the front and the back. I think we're gonna go wide, the Squish X. So I'm gonna make it wider than it is long by making this, let's say, an inch. So I have an inch clearance tip to tip, left to right, and I have about 1/3 of an inch clearance front to back. What you gotta do is make sure that you leave yourself plenty of room around there. I might even say, let's take this prop and we can make an offset of like 1/8 of an inch. And then I'll just make this a dotted line here. Because these props at full speed, they have a tendency to grow a little bit. And not only that, everybody's prop is slightly different. So I've laid out some frames where I only gave myself just the tiniest little clearance, and I go throw a prop on there that's supposed to be that size, and it ends up hitting the standoffs because it's just a hair oversized. Fender's trying the theory of flying 6-inch frame with 5-inch props. What's the theory behind that? .1? It changes the whole design. Well, here, what's nice about this, right? The way I set this up is I gave myself prop clearance, inch and 0.3 inches. If I were to, let's say, use that dimension and I want 5 inches, then I can't change my prop diameter later. But the way that I set this up, by doing it this way, I can come over here and I can make that 5.1 inches, and boom, my quad's bigger, and I still have the same gaps. So, good way to set your quad up to start. Just put your clearances in there rather than defining, some people will strike a circle here. All right. That is your frame size. So if I come over here and measure that, and let's make that driven. Okay, so my frame size right now is at 815. And let's see millimeters. Okay, so right now at a 5.1 prop size, the frame size is going to be 207 in millimeters. And because I'm driving this whole entire design with the prop diameter, I can change that down to 4. Everything updates. and you'll see a 4-inch prop is going to make this frame size a 167. Let's see, what are we saying about the 5-inch props on a 6-inch frame? Your props get cleaner air, and reducing some of the niggles that you get. Stretch X does the same. Okay. Do you think it's better to stretch the frame the long way rather than the wide way? To me, it seems like if the frame is long, that would get you cleaner air, right? Because your front and your back props would have a little bit more room between themselves. Is that right? Because most of the time you're going forwards. Unless you're Stuart. Where's Stuart? Is he in here? Stuart doesn't go forwards all the time, does he? Go long. So maybe make this the long dimension here, and then we can kind of tighten up the frame here. We can go even longer too, I suppose. Give us more room for the battery. Should we let it breathe? Should we open it up and really give ourselves plenty of room so we're not being silly here? Only a 1/2 inch longer on the arms. JT, when you say the Squish X, is that wider than it is long? Squish wide and stretch long? Is that the correct terminology? Why would JT want to copy? You're not telling me to copy EMS Thomas, are you? No. You're gonna be beating him pretty soon anyways. It's wide like an alien. Okay. Yeah, I want to go back to that. Let's say 0.4 and 1.5. But we're gonna do it with a 4-inch prop for Smarky. That's what he wants. All right, so that's like, it's a little bit under 180 millimeter frame. Squish is wide, okay. I'm going to bail out of that sketch and keep that in the background. That's just a reference for me to know where everything's going. 20 millimeter stack? Yeah, definitely. These days you'd have to be crazy to go with the old 30 millimeter stacks, right? Okay, let's start dropping parts in here, right? Let's see. Everyone can go check out my folder structure here. Where are we going? Overflow. Still flies well? Yeah. Let's drop some motors in there. What are we putting for motors? We kind of went with the 4-inch frame, right? So what are we doing for 4-inch motors here? 1407s? Yeah, watching BMS Thomas on the spec track at Muncie was pretty impressive. He was way cleaner than everybody else, you know, just real smooth around the track. And when he needed to just take the speed up, just notch it up a little bit. I mean, it was right there. I mean, there was other guys there that could just, you know, punish their quads, but nobody could like thread the track like that. It's definitely cool watching those guys fly. I don't know. I'm excited to see the big quads when the weather breaks here. It's got to be pretty soon. So what are we using? Yeah, what are we using for motors? What do you guys want for motors? I'm looking through my motors right here that I already have drawn up, and here's the drop that right there. That guy is the DYS 1407. His lines are perfect. Yep, I would agree. What do we got? Float, please. There we go. Mm-hmm. $14.07s. All right, this is a 1407. This one's modeled after the DYS SC 1407 that I've got on my 4-inch quad. So I don't know if you caught it, but the first thing I did was I attached the base of the motor to the top plane so that it can't go anywhere. Next thing I gotta do is just locate it on the center of my prop there. So I'm picking that point, and I'm picking my shaft, and I'm saying that it needs to be concentric, and accepting that. Alright, so now my motor is stuck there. All it can do is spin. Can't go anywhere. And that's on my prop. There's my top view. Right? And nice thing about being in the computer is you can copy paste. So I'm going to go to my assembly, grab that motor, and say that I just want to mirror it. Mirror it across the right plane. Bing, there we go. And I'm going to mirror it one more time. This time across the front plane. U and U. Boom, there's my motors. Sorry, had to tinkle. You missed voting for the motors. We got a little 1407 stuck on this frame here. All right. And still, the way we started this, if I go back here and change this to 5, the motors are still attached to those points. So they're going to go with the frame wherever we decide they need to go. If we go down a 3-inch prop, everything is still alive and parametric, responsive, whatever you're going to call it. I don't know. But it's a good way to design. You know, starting off, sometimes you draw the main circle. You're like, oh, I'm going to make a 180 millimeter quad. So you end up drawing this circle first. And then if you decide you're going to change something later, you're kind of stuck. Takes a little bit of work to go back and fix that stuff. Now, let me see if I've got a 4-inch prop as well. Let's see. 4-inch prop. 4. 5x3. Maybe in one of these. No. I should get better organized with my parts, huh? 180. Yep. Alright, we don't need to drop a prop on there. We can put a battery on there. What are we putting on this thing? 4-cell 1000? Is that what you guys are flying with? I draw all the motors up myself. There we go. So I'm just grabbing a battery that I drew up in the past. Like so. And we're going to kind of find a place for this guy. How do you guys like to attach your batteries these days? Top mount? Bottom mount? Down here? Up here? Down? I've always liked top mounted. For freestyle, I think it's necessary. In racing, it doesn't seem to matter as much. And most of my, I think all of my racing quads have the batteries strapped to the bottom. You say bottom? Alright. This guy is just kind of floating out there, so I want to straighten it out. I am just going to grab the, let's see, top plane of that battery. Yep. And attach it to the right plane of my drone here. There we go. That looks good. We'll just kind of let that chill down there for now. Drop the battery in. Now I can visualize that space. And I know I can't put anything there later on in the design. Top would be weird for a 2020 stack. You could still do it though. I mean, you can throw that battery up there, start stacking your electronics underneath, you know, and just put a little like breastplate type thing on it. Throw your camera right here, right in between the props. Camera mount's always what gets me. It's like the last thing to do, and there's nowhere to ever put the dumb thing. But we can go bottom on this one. Weird is the new normal. Weird is normal with you. Alright, we got a couple parts in here, so I'm going to start drawing the actual frame of the quad here. So I'm going to insert a new part, attach it to the top plane. Okay, so 3D printed, yeah, that's making life a lot easier. Just 3D print it. You can make it fit wherever. So I don't know if you caught this. You guys don't know SolidWorks, but anyways, I'm still in my assembly. I have all my parts here, but what I'm doing is I dropped a virtual part into this assembly, and I'm editing that part. And I'm working on the top plane here, and we can start by just drawing one of these arms here. Alright, I'm going to switch over to metric now because we're basically done with the only part that's in standard, which is the props. So flip back over to metric, and from here on out everything is metric. So I'm going to take a look at the arm. How did that dude donate money? Who donated money? Oh man, I didn't even see. Oh sweet. Thanks, Mark. You're alright. I take back what I said about you yesterday. Alright, let's see. 10 millimeters? 10 millimeters sound like a thick enough arm for a 4-inch quad. Man, that looks skinny. That looks really skinny. How did he do it? He went to, he either did it from the link that I had in Twitch, or, let me see, I will paste the link into chat right now. 1 second. Copy. Pasties. There you go. So if you follow that link, then you can throw the donations at me. If we get enough donations, that's going to cover buying all the parts so that we can build this thing and give it away. Hopefully we can raffle it off to all the guys that donated. That's what I'd like to see. But we'll work with what we got. Yeah, today we're just gonna kind of design this thing in SolidWorks. Next week, we're gonna work on setting up the machines in order to machine this out. Hopefully, we'll be able to live stream the CNCs, cutting the carbon, the 3D printer printing, and then third week, we're gonna do all the assembly, do the programming, and fourth week, I say we'll fly it. We'll have to, I'll bring the portable streaming setup, and we'll have to meet up out in the field. And first things that's going to happen is when I arm it, it's going to freak out. And I heard that it's called the Taz, doing the Taz, Tasmanian Devil. Yep. Even after I don't know how many years, 3.5 years, I'm still making quads that do the Taz. Very sad. All right. What do you think of this arm here? Is this thing thick enough? I'm saying that it's 10 millimeters wide. Now I'm gonna do the emboss here, and we're gonna say 4 millimeter arm. All right, we'll catch you later. Thanks, JT. Thanks for stopping in. All right. There we go. That's what a 4 millimeter arm would look like. 10 millimeters wide. That is sketchy thin. But I don't know. We can make it work though, right? All right. Now we're gonna need a motor mount. See, get back in. Give myself a little pad for this motor to sit on. That out. About 18 millimeters. Let's see. You can kind of see these dotted lines here are the screw holes for the motor mount. So I'm just going to draw a circle here and make sure that it's big enough to catch those mounting holes, right? So 17 is good. 18 looks like it would be about the same size as the motor. So let's do 18. All right. And we're going to extrude that. This time I'm not going to say it's 4 millimeters. I'm going to attach it to there. That way if we change the thickness over here, thickness over there is going to change, right? This 4 millimeters, change that to 6. Make that whole arm thicker. And go back to 4. There we go. JT's got a curfew. He's not as young as he was last year. Right? Getting older right before our eyes. Okay, before I get too much further, this arm is floating still. So I'm going to now lock it down. So I'm going to find my planes. See, top plane there, front plane there. Going to lock them together. Very good. And right plane, lock those together. Okay, now it can only move up and down. And where are we attaching it? We're attaching it to the bottom of that motor. All right, now if I grab that arm, it won't move. It is locked in place. And the battery, we can now say that it is going to sit on the carbon just like that. Okay. Now we can still slide the battery front to back, which I'm going to leave that free for right now. Because later on, what we're going to be able to do is we're going to be able to check the center of gravity. So if I hit my mass properties and create center mass feature and make it visible, there, right there, that little dot there is our center of gravity as it sits right now. So these parts that I've drawn up previously, I've weighed them and entered that weight into SOLIDWORKS so that it is doing the calculations properly. So it knows how much this motor weighs, knows how much that battery weighs. This, as of right now, it does not know how much it weighs, but all we got to do is come over here to material, and we just have to change this material to carbon fiber. There we go. Of course, I don't like staring at that carbon fiber texture that they do. I'm just going to delete that. There we go. That's better. I'm happy. Actually, we could make it, maybe we make it just a little bit darker gray. and then I'll keep that straight in my head that that's carbon. Okay, there we go. So I can open this part up and I can evaluate its mass, and right now it's telling me that this arm right here, 4 millimeters thick, made out of carbon fiber, weighs 8.8 grams. So we can keep an eye on the weight as we're building. All right, put that away. Probably a good time to save my assembly before I get too carried away here. SolidWorks has been known to crash from time to time. Live stream quad 1. Save. Alright, cool. Now it's too heavy. I'm still working on this one arm here, because what we're going to do is once this arm is done, then we're just going to mirror it to the other sides and the full quad will be done. Alright. So next thing is the holes for the motor mount. So you can open this up, and generally these motors need a little bit of clearance for the shaft to stick out of the bottom. Let's call that maybe 6 millimeters. A little bit of clearance for the bearings and the C-clip and stuff. And so we will punch a hole through, there we go, through the arm right there. And then going to put in our holes. So I'm bringing up the hole feature, and rather than drawing circles, this utility here lets me define what screw I'm putting through, and SolidWorks does the calculations for what size that hole is supposed to be. So I don't need to look up in my book the proper hole size for a 3 millimeter fastener. This is going to do the work for me. So pop over here to clearance hole for a metric screw M3. Right here I have the fit, so you can make the hole tight, normal, or loose. I'm just going to keep that on normal, and we're going to go all the way through, and we don't need a countersink. And then we'll drop my holes there. Oop, I'm getting ahead of myself. We don't need to do that. We just need one. Okay. One hole there. And we're going to make a pattern from that one like this. Circular pattern. That's our center point. We have equal spacing of 4 holes all the way around. Bing. There we go. There we go. That hole looks way too big. I'm having a thought that this motor might not be M3. It is not, it's M2. Alright, if you look over here, let's see. We've got about a 8 millimeter hole for the bearing, and we have M2 holes, and they are 6 millimeters from the center, so 12 millimeters across. All right, very good. We can fix that. Go back over to my arm, and we can edit that feature, and we can tell it that we are not M3, we are M2. Right. And we can take this and make that 6 millimeters to match the motor. And then the last thing is figure out some kind of orientation here. Right? One way we could do it is kind of center that hole up right there, and that'll kind of give us some strength through this direction. Or we can kind of move our holes over here, and that gives us good strength to here, but it kind of kind of gives you a point of, you got a lot of stress right across there and there. I kind of want to maybe line the hole up there and let the material flow on either side of that hole there. So I'm going to take that line and I'm going to point it back here at that. There we go. Cool. Let's see. That is not machinable right there because we're going to be cutting these out with round cutters. And if we could, it would make that a point of stress there. So I'm going to take and put a fillet there, which is this little roundy thing here. And I'll probably make that 6 millimeters. There we go. Nice and smooth. I think I noticed that this should probably go up to 8. Cover that bearing. Go. Save that. Back to our assembly. Alright, now our motor, we can bring that around. There's our tapped hole, and we can lock it in to our clearance hole. And now that motor's not going anywhere. It is attached to the arm. There she is. Never used SolidWorks before? Yeah. This is the one I use the most, so I am the fastest in it. I've been trying to teach myself Fusion 360 just because you can kind of stay up to date. I can't afford to carry a subscription for SolidWorks because it's very expensive. Fusion 360 is way cheaper, or free if you're a hobbyist. So I would like to learn it, but man, after spending the last, decade in SolidWorks, it's it's getting harder and harder to learn these. It's not new software, it's the same software. The problem is it's goofs up all the hotkeys. Nothing is the same. I don't know where to find anything in any of the menus. And when I know that I could do it so much faster in SolidWorks, then it aggravates me. All right. Inventor and Pro E. I have not used any of those. SolidWorks pretty much where I started in CAD. I used Maya a lot before I got into SolidWorks, because I was doing non-engineering things back in the day. Thickness, how thin would you feel comfortable making the arm? Not the thickness of the carbon, the arm coming from the body to the motor. I already feel like 10 millimeters is pretty thin. I mean, what do you think? Actually, let's do our mirroring operations now, and we'll start to see what this thing looks like. So I'm gonna go to mirror, and we'll mirror across the right plane. I'm just gonna grab that body mirror, and one more operation. I can't do a circular pattern because it's not an X. If the quad was a perfect X, I could do that as a circular pattern. But because we're not symmetrical on that diagonal axis, we're just going to mirror twice. Oop. I grabbed the wrong plane. What do we got? Top plane. There we go. There's our quad. Sweet. Done. Throw a rubber band around it and we're ready to roll. Hot glue that flight controller on. 3D print ourselves a little camera mount. I think we're ready to fly. Man, those those arms look thin. Those arms are definitely strong enough to fly. They're strong enough to tumble in the grass. But a good hit on a gate post, and I think those would be gone. We could tie front to back. We could run a little stringer here, front to back, That would make it stronger too. I say we probably, I'm seeing so many quads with really thin arms. But let's leave them thin. Maybe we'll go thicker. I don't know. We'll see. But that's pretty good there. And we can kind of check our weight. We can see where we're at so far. Pounds. I don't want pounds. We gotta switch to metric here. Options. Yeah. Metric. There we go. How much do we weigh? 220 grams. Oh, we got the battery on there. Okay, so with the battery, 221 grams so far. Not too bad, right? We're still under our target. This is going to be a 250 gram quad here. We still got some wiggle room. 10 is fairly wide on 4. 8 is more common. 8, man. 8? Jeez. To me, it just seems like seems to me like you're breaking arms at that thin. I know it needs to be under 250. I came up with that number. Hopefully we can stay under 250. If we're at 220 already, we're pretty close. But I don't know. That's a lot of battery. It could probably fly with even less battery than that. Alright, what do we need next? We need to punch some holes in here for a flight controller stack, right? Go in here, let's see. Start drilling some holes. So these holes, we know that these are M3. And they're going to go through the whole thing. And let's put one down. Give myself